Hi, my name is Markus. I work for the Siemens AG in Munich, Germany. Today I'm representing our team consisting of Florian, Joachim and me. In the last months we worked on an architecture pattern which we call the connectors. In the last days we talked a lot about this, also with our attendees here at the SATURN. And some guy told me, hey, the connectors sounds a little bit like a Hollywood blockbuster. Sorry guys, it's a software architecture pattern which we talk about today. But I want to start with a challenge and a problem like in a movie we addressed with that software architecture pattern. And I will shorten that a little bit after the two talks we get before and also after the keynote. We have came up from the DevOps movement. There are some new demands, some new challenges and problems which came up due faster and more flexible deployment of software updates. And we know there are a lot of techniques and frameworks like containers, and even Java 9 came up now with a module concept which can help in this environment. And we try to solve that problem with an architecture pattern. Okay, by using this pattern, we promise you some quality attributes. And the first one is flexibility. What we do is separating software components from each other by separating the interface which connected these two. And we add an additional layer between these two, which we call the connector layer. And now we decouple that two components and get more flexibility into the system. What else did you get by using this pattern? It's a more structured system. You get more structure because you want to have orthogonal services in your system. An orthogonal service is monitoring, a performance analysis, a parallel execution. And you can keep your application logic, your application code clean by putting all that orthogonal operations, all that stuff into the connector layer. What else did you get is transparency. That's important for the operation team. They want to have insights into the system for monitoring, profiling and that. And you can control the orthogonal services dynamically during runtime because you can control now these orthogonal operations. Okay, this report is structured as follows. First, I want to give an overview to a typical application field we are working in at Siemens and where we use the connectors. Then I will give some insights into the theory behind the connectors. I explain the difference between an unloaded and a loaded connector. And finally, I will give an example how we can use the connectors to upgrade a system while it is in an operation. So let's start with our application field with the use case for this presentation. So we at Siemens, we have a strong focus on automation and digitalization in the industry. We build power plants, high-speed trains, or production facilities. And all of these systems have in common that they control physical processes. They work in regulated environments. And in this environment, it's very difficult or sometimes even not possible to shut down the system to upgrade software. We have to make updates while the system is running. And what other characteristics we have in our systems, at least sometimes, is a very reduced hardware. The hardware is just for one dedicated purpose. And to summarize and to simplify that system characteristics, we have here on the right-hand side our RoboSat 17. It's a robot just developed for the purpose of this conference, for the SATURN 17. And this robot drives through a production facility, collect parts, which he needs to build a bigger product. And therefore, you have a navigation module inside, which calculates a route to the next part it needs. And also to address the characteristic with the expensive downtimes, we have here the case that a charge or a change of the battery is very expensive. So you see here the robot, how he drives through the production facility. He collects the next part which he needs, and the routing algorithm calculates the red dotted line. But there is a problem. Another robot blocks a path, and we have a waiting time. So the fastest route is not even the best route, and the production manager wants to have a more efficient and eco-route algorithm. So therefore, he talked with the development team, and they try to implement a more efficient and more eco-routing navigation algorithm. And after it is finished, of course, they want to test it. And this test should take place in the field. We want to have a field test on the running robot parallel while it is running. It's very difficult because we don't want to have any impacts on the running system. Why do we want to do this? Is the case that we keep our quality attributes in mind. First of all, we need a reliable system. There can be human beings who are also working in the production facility. What else do we have is the demand for a high availability. We do not want to shut down our system just for upload a new version of the navigation algorithm. So we want to do that in the field, run a parallel algorithm side by side. Okay, that is our application field we are talking about for the remaining part of this presentation. Now I want to give you some insights to the connectors. And we have here always two views on the problem. On the left-hand side, there is always an UML similar view on that. And on the right-hand side, it's in C++ speech of the problem. So please decide which is the appropriate version for you. And I want to start how we use typically an library. Here we have a client. It is our robot. That robot needs a capability for its navigation, which is implemented in an open library. And therefore, the client uses that library by the public interface, and we have a reference from the client down to the provider. We have a coupling of that two software components. What we are doing is we separate that interfaces with a lot of other stuff inside the connector layer. And now we have a reference from the client to the connector and from the provider to the connector. But client and provider are decoupled from each other. They are independent. You can develop and deploy them independent from each other. And you have now no reference from client down to provider or vice versa. Next, I want to show how the client's view to the connector. So like I said, the client needs a capability for the navigation. Therefore, we have in our connector a navigate capability as an interface. But the client should not use that interface or any implementation of that capability. No, he should access that capability via a factory class. And in our case, it's the chassis class. The chassis class works as a factory for the client to get a capability for the navigation. Now you get a stronger focus on the connector itself, and we talk here about an unloaded connector. Unloaded connector means that we have no provider below, and we have no orthogonal operations here. We have no monitoring, we have no switching or parallel execution here. What is important to notice here from this slide is the B section of the factory class chassis. We have a public function navigate, which works as a factory that returns an instance of the interface of an implementation of the interface navigate, which can be seen by the client because it's public. And we have a protected function implement inside, which returns an instance of this interface navigate. And what we see here is now that we implement the interface navigate with the navigate default class. It's just for a mocking purpose. Maybe we have no provider, but we want to test our system. And therefore we have here a simple mock which returns a static value for the root. Again, we extend this example. Now we have a loaded connector. We have a provider below our connector, and we put here now an orthogonal operation. This operation is switch, and therefore the class which was navigation default on the last slide is now the switch navigation. In this class, switch navigation, you have a nested instance of the fast routing algorithm. Why do we call it switch navigation? In this class, you can connect a second provider, our EcoRoute algorithm in the future. And then you have here a switching component, and you can decide which of these two routing algorithms you want to have as the routing algorithm, and you can have here also a test. So the switch navigation works here as a proxy to manage the access to that instance of the routing algorithm. Okay, I talked a lot about many common patterns, and I want to mention that we implement our pattern on well-proven and established patterns. 3 of them I want to mention in detail. It's the separated interface pattern by Martin Fowler. I talked about that from the first slide on. We separate interfaces in an additional layer with some other stuff to decouple client and provider from each other, to be more flexible, to be able to deploy and develop these components from each other. What else is necessary for the connector pattern? It is the abstract factory and the proxy pattern, both from the Gang of 4. These are necessary to keep that decoupling alive. We want to manage the creation and the access to the capability, and we want to hide the client from the provider and vice versa. Okay, that was a deep dive into the technique of this pattern. And like we heard today in the keynote, details matter. And excuse me if it was too deep, but that was the little nerd in me. Now I came back to a more abstract view. I talked about the example that we have different providers, a fast route algorithm and an efficient or EcoRoute algorithm. What else can we have? We can have different client, and you want to prioritize this client. You can do that also in a connector. That is the vertical axis, how you can use connectors. You can use them also in the horizontal axis. That means you put orthogonal services here in the connector, like monitoring, parallel execution, or a switching. And you can do that dynamically during runtime without restarting your system. And all of that we make use of in our DevOps environment. We have here our robot driving through the production facility, and now we want to deploy our new EcoRoute algorithm. We do that by usage of our CI server. The CI server will build our new provider, our new software component, load it onto the robot by using Wi-Fi, for example, and then he uses the gateway. We have a gateway in the connector, which is the entry point for commands. And he can send a command to tell our connector, hey, you got a new version of the routing algorithm. Please deploy it and test it in the field beside the already running algorithm. Okay, that were a deep dive into the connectors. And now I want to show you how we can use the connector to upgrade a system in operation. We want to test now our EcoRoute algorithm. That we are doing by a blue-green deployment. The fast route algorithm is still deployed on our robot. It is stable, it is well proven, and now we want to test our EcoRoute algorithm. Therefore, we deploy a second provider side by side in the field and parallel to the fast route algorithm. We use, therefore, the strategy pattern. This is like a configuration for our switching component inside the connector here. And the configuration says, please dispatch all calls to the fast route algorithm and test in parallel our EcoRoute algorithm. And after a successful test, you see it on the right-hand side, we want to set our EcoRoute algorithm as our primary navigation algorithm. Therefore, we change our strategy and we dispatch now all calls via the switching component, our orthogonal operation switching inside the connector. We dispatch all clients, all calls now to the EcoRoute the fast route algorithm is still deployed and can be used as a fallback if anything goes wrong with the eco route, or you can even undeploy it because it's now unnecessary. Now we extend that example with a regression test. That's also inside the connector an additional orthogonal service. And again, we change our strategy. We dispatch all calls, the normal usage of our robot, to the fast route. And we want to test the fast route and the eco route algorithm in parallel and compare the results as far as possible, inside the regression test module. On the right-hand side, we listed some other operations which can be implemented inside the connector layer. For example, you can also implement an parallel execution. In a safety critical system, you can have the case that you must implement an algorithm with 3 different implementations. And you can deploy all of them to the connector, run them in parallel, and then compare the results and make a 2 out of 3 decisions inside our connector layer. Okay, now I want to summarize the benefits for the development and for the operation team. For the development, the domain experts can now focus on the real application scope. They do not have to think about any orthogonal operations. They can keep their code clean because they can put all inside the connector layer. And you get, therefore, a more structured and a more clean software and a more clean system. For the operation team, there are also some benefits. They can now fulfill the requirements from the development team for faster releases, for more frequent releases, and also from the release of only parts of the system. And they get faster and better feedback because they get more insights into the system by adding orthogonal services. So on this big picture, I want to summarize the benefits in a DevOps environment. We have here now 3 swim lanes for the different providers. We have in provider A1, A2, and B1. All of this provider have different and separated backlogs. They have different development processes. Maybe A1 is developed by using Scrum, whereas provider B1 is developed by using a waterfall process. They have different release cycles, and whenever a provider wants to deploy or test a new version, they use the CI server that tests and builds that software, loaded it on our robot while this robot is in operation. Then we use the gateway to set up the command to deploy a new version and can test any new version of the software in the field on our running robot. We get faster feedback. We keep our availability alive. So now I want to summarize and hold the promise I made on the first slide. I said you get more flexibility. We achieved that by separating interfaces in an additional layer. We decouple client and provider from each other, and they are now flexible and independent. You can develop them and deploy them partly. And the next thing you got is more structure. You have this connector layer between the client and provider where you can put any orthogonal operations like monitoring, parallel execution. And this is the fact that you get more transparency to your system for the operation team. You can switch on, switch off all of these orthogonal services while the system is running. You do not have to shut down the system to get more insights. So that's all. And now I'm excited about your questions.
Questions?
Hi, thank you. So your bit about testing was very interesting. My question is, in terms of regression testing, I presume you want to see something like the same results given the same input, but how, when the robots are in the field, do you compare results of a regression test to a previous regression test?
Of course, for a navigation algorithm, it's very difficult because the routes must be different. So you can't only check if the destination of the route is the same, for example. And you're right, for physical processes, it's very difficult because if the algorithm requires online data, like from sensors, then only the primary algorithm gets the real input, and the second algorithm gets only the input, but cannot have any influence on that. So it's not that easy. Yes, you're right. So you can only have partly a regression test, yeah.
Other questions?
Yeah. Yeah, for example, you saw it on the slide with the wrapper class. And you can make a performance analysis here by taking a timestamp before the call and after the call. So you get an insight where you lose your execution time. Where are the most demands for execution times?
I guess I meant more on the connector itself.
Sorry.
What are the drawbacks of connector, like performance-wise?
What are the drawbacks by using the connectors? They are very lightweight, of course, but you can put a lot of orthogonal services in. So it depends on what orthogonal services you use here. If you use, for example, a very heavyweight connector, which uses for parallel execution separated threads and processes, then it's more costly than you use, for example, just one thread. So you can blow up the connector like you want. So it depends on the implementation.
Question on getting the test feedback or the result from the robot back to the developers. If the robot is talking back to the CI or similar environment and send the result to developer, because developers need to know the result or the testing, what's going on in the real field.
Yeah, you can also implement an interface like the gateway, which is the input for any commands or data. You can
so
use
like gateway is talking backend, you mean? Backend means like you have a CI server, right?
Yeah.
So CI server is able to somehow communicate, pushing the build to the robot, but this robot is able to send the result or testing result back to the CI like environment?
Maybe not to the CI server, so better to any logging server.
Logging server,
But
okay.
I think it's possible, yes.
Okay, thank you.
It's also a special kind of an orthogonal service, yes.
Any other questions? Okay, thank you very much, Markus.